Okay, for this question, there's a couple of things we need to do, but basically the aim of the exercise is to get us to be able to sketch it with as much information as possible. So let's just have a look at the different sorts of things we might do to be able to do that. The first part of the question actually says to find the stationary points, but before that we actually need to find the derivative. So I'll find the derivative by using the power rule on term by term. We get 4x minus 3. I know that the stationary points will occur when the derivative is equal to 0. So I'm going to set this equal to 0 and then solve. I get 4x minus 3 equals 0. So that's at x equal to 3/4. That's where the derivative is equal to 0. That means this is a stationary point. The next thing that I want to do then is determine the nature of this stationary point. So we're going to devise a little bit of a table here. I'll put my stationary point in the middle, and I need to pick a point that's a bit to the left and a bit to the right. Pick points that are fairly easy to work out, so I'm going to pick 0 and 1. We already know that the derivative at this point is 0. That's what we found. So we found the stationary point here. That means the gradient is flat. At the point where x equals 0, we can see that we're going to end up with -3, so that's a negative gradient. And when it's 1, we've got 4 minus 3 is 1. It's a positive gradient, so we can see here it curls down, bottoms out, and curls up. So we're actually going to call this a minimum turning point. That's the nature, and now we can put all this together and have a bit of a sketch. So to sketch this, we're going to do a few things. The first thing we'll do is we'll mark on our turning point. We know that it happens where it's 3/4. So I need to work out what the y evaluated at 3/4 is. For that I'm going to use my CAS. I'll type in my function 2x squared minus 3x plus 5. I want to evaluate that, so I go to my math options tab where that x equals 3/4 and execute it. I get that it's 31/8, which is 3.8. So it's up here, 3.8, and that is my minimum value. Now when x equals 0, I'm going to have a y-intercept of 5, and I'm decreasing through there, bottoming out, and then increasing. That's all the information that we need to put on this particular drawing. The next quadratic that we're given is already in factored form. That'll help us with the sketch, so I might even start by putting some details on there already. I can see I'm going to have a root here at -5 and a root here at 1. To find the stationary points we need the derivative. To save using the product rule here, what I might do is expand it first. So I'm going to get 5. I've got plus x minus 5x is minus 4x minus x squared. And then when I take the derivative, I end up with -4 minus 2x. When I set this equal to 0 now, I get -4 minus 2x equals 0. Let's set up our little bit of a table here. X and y dash. Instead of evaluating at points, I might just look at this one's okay. We'll do the evaluating points. So I need a point to the left and a point to the right. Point to the right, I'm going to pick 0 because that's fairly easy to work out. When this is 0, we know we've got -4, so it's a negative there. We can see here that we already know that that was 0 because that's what we worked out. And then a point that's a bit to the left of this, let's pick 3. So we've got -4 plus 6 is +2. So you can see I'm going up, flattening out, bottoming in, and then turning around and coming down. So what I have here is a maximum turning point at this point where x equals -2, sorry. So x equals minus 2. We've got to have a maximum turning point. Let's have a look at our function here. When x equals minus 2, I've got 5 plus 8 is 13. Minus 4 is 9. So I'm going to be up here. I have to go through this point, through this point. This point here will happen at 5 when x is 0. And that's all the information we need to put on that graph.